Introduction to Machine Learning. Implementation of K-means clustering for customer segmentation. In this video, we're gonna talk about objective of the experiment, program implementation, execution and result, and also application of clustering. Objective. The objective of the experiment, which implements K-means clustering for customer segmentation, is to group customers based on their similarities in terms of annual income and spending score. By clustering customers into groups, business can gain insights into different customer segments and tailor their marketing strategies, product offerings, and customer service approaches to better meet the needs and preference of each segment. They also have specific goals of the experiments might include identifying distinct customer segments based on their purchasing behavior, understanding the characteristics of each segment such as their average income level and spending habits, exploring relationship between different customer segments and business metrics such as customer satisfaction, retention rates, and profitability, developing targeted marketing comparisons and personalized recommendations for each customer segment to enhance customer engagement and loyalty. Overall, the objective is to leverage clustering techniques to uncover valuable patterns and insights within the cluster data, ultimately leading to more effective decision making and improved business outcomes. Now let's see the program implementation. First, we are importing the necessary libraries: Pandas as PD for data manipulation and analysis, NumPy as NP for numerical operation, K-means and sklearn cluster for K-means clustering algorithm, Euclidean distance from sklearn matrices pairwise for computing pairwise Euclidean distance between points, matplotlib.plyplot as plot for data visualization. And now, reading data. The code reads the data from the CSV file located at here into your pandas data frame named data. If we run the program, we have 5 columns are displayed. The next step, selecting future. The code selects the columns annual income and spending score, that is 1 to 100, from the data frame data and assigns them to a new data frame X. Now, visualizing data. The code plots a scatter plot using annual income as the x-axis and spending score 1 to 100 as the y-axis. This visualizes the distribution of data points in the future space. Setting number of clusters. The variable k is set to, indicating that we want to cluster the data into 5 groups. A k-means model is initialized with n underscore cluster equal to k, specifying the number of clusters. And now fitting the model, the k-means model is fitted to the data x, getting centroids and labels. The code retrieves the centroids of the cluster using cluster underscore centers attribute and the labels of each point using labels underscore attribute. Now, visualizing cluster. For each cluster, filter the data points belonging to the cluster. Scatter point this plot with your distant color. Calculate the maximum distance of your point in the cluster from its centroid. Draw a circle around the centroid where it is equal to the maximum distance. Plot the centroids with stats. Styling and finalizing the plot. Add title, X label, Y label, legend grid and equal aspect ratio to the plot. And here is the display of the plot. Here is the executions and here is the result. And now, application of clustering. Clustering is a fundamental technique in data analysis with a wide range of application across various domains. Some common application of clustering are cluster segmentation. As we said before, in the provided program, clustering is often used in marketing to segment customers based on their purchasing behavior, demographics, or preference. This helps business understanding the customer base better and tailor product, services, and marketing strategies to specific segments. Anomaly detection. In anomaly detection, clustering can be used to identify anomalies or outliers in data. By clustering normal data points together, any data points that fall outside of this cluster can be considered anomalies, potentially indicating fraud, errors, or other unusual events. Customer churn prediction. Clustering techniques can help identify a group of customers who are at risk of churn, that is, discontinuing their subscriptions or service. By understanding the characteristics of these groups, business can take proactive measures to retain customers. Image segmentation. In image processing, clustering algorithms can partition an image into meaningful regions or segments based on pixel values, colors, textures, or other features. This is useful in tasks such as object recognition, scene understanding, and medical image analysis. That's it for today's video. Thank you. See you in the next video, guys. Bye bye.